Okay, piglets and petunias, welcome to your review. I read through and graded your review sheets yesterday, and they were not in fabulous shape, so I'm going to go over them with you, and this will take about 15 minutes. So check your study guide as we go through. I have your notes on the screen, and you'll see the red highlighted parts actually answer the questions. Okay, but they do not go in order. So listen for the question number. Number 1, what are some signs that a chemical reaction is occurring? Right in your notes it says bubbles, gas given off, light, heat, precipitate or solid forming, and change of color. A lot of you gave this top part, which are examples of chemical reactions. Okay, the signs of the reactions are in red. Products and reactants, number 2 and 3 on your study guide. You need to know reactants react. We read from left to right in the English language. So reactants are what we start with. Products are what we end up with. So reactants left, products right. Number 4, are atoms created or rearranged during a chemical reaction? So laws of conservation of mass and energy, we don't create or destroy matter. Okay, we only rearrange them. Like here, you have oxygen in 2 places. We arrange it into the compound SO3. Okay, and then we started talking about activation energy, and that led into numbers 5 and 6, exothermic and endothermic. Endothermic reactions, it's where the reactants absorb energy to become the products. Okay, exothermic is different because it's a reaction where the reactants release energy to become the product. Okay, you should be familiar with both the terms, the definitions, and the examples in your notes. Okay, you do have a couple graphs on the test that you should be able to read as promised. So remember, exothermic, that's the one releasing energy, like a roller coaster. Endothermic is where you're absorbing energy. You're putting energy in to make the reaction happen. Okay, so now we go into the 5 types of reactions. Synthesis. Your key word here is where I'm combining. I'm forming something new. Okay, and there's your picture. You are going to have pictures on the test, and it's going to be part of your open-ended where you have to identify the reaction type. Okay, so synthesis. I made something new. Combustion, to combust is like to burn, to have fire. So you always have something with carbon, like your gasoline, and oxygen, like candles need oxygen to burn. So, and that answered your number 8 and 12. What reactant is always supplied for combustion? Oxygen. It's right there. A bunch of people got that wrong. Okay, and there's your pictures of combustion, carbon and oxygen. Okay, carbon, oxygen, carbon, oxygen. Decomposition, so to decompose, we are on number 9. Okay, it's where you break down. So if I have one compound and I break it into its parts, that is decomposition. Single replacement, you have one element taking the place of another. Okay, so it's a swapping, trading places. So if I have a compound plus an element, and I have a different element plus a different compound, I traded places. Double replacement, yes, I know I'm going fast, but this is all in your notes. Double replacement is between compounds. Okay, so I'm exchanging the ions, the charged particles. So compound plus compound makes a new compound plus a new compound. It's a double swap. Okay, so pictures like this you should be ready for. Your next topic goes into, we're at number 13. What does the law of definite proportions state? Right down here. The law of definite proportions. Coefficients show the number of moles, but it states this is why we balance reactions, because we're not destroying or creating mass. We're conserving it between the reactants and the products. That's why we balance things, and this actually answers number 41 as well. These are your equations. You have some of these you're going to have to do on the test. You need to know how to balance. If you don't remember, go back to your worksheet pages. Okay, so like zinc, zinc. Okay, 2 hydrogens, 2 hydrogens, 2 chlorines, 2 chlorines. You have to change the coefficients, the numbers in front. Another type of question you're going to run into on the test, down here it tells you the coefficient shows you number of moles as well. So if I ask you, let's look at the second example, how many moles of aluminum react in this equation? Okay, you look at the coefficient, 4. If I ask you how many moles of hydrogen are produced in the fourth reaction, well, produced are this side, I said hydrogen, so you would say 1, okay? Because this hydrogen is part of a compound, it's not by itself. If I ask you how many moles of aluminum oxide are produced in the second equation, aluminum oxide, there's 2 of them. So these numbers aren't just balancing for fun, they're balancing the number of moles, the ratios or amounts of the substance. Okay, now we're on to number 14. What are some things you can do to make a reaction slower? Most of you got this right. So you could lower the temperature, have a smaller surface area, less concentrated, or have a massive bulky molecule. Okay, and now we're actually going to jump down towards the bottom of your study guide. Okay, we're going all the way down to number 34. Okay, so catalyst, remember that's the general term, and enzyme, here's the important slide, are specifically proteins. So the answer to 34, are enzymes proteins? Yes, they are proteins. They're 3-letter ending. That's also on the slide, question 35. ACE, A-S-E, amylase, lactase, anything ending in ACE. Number 36, what do enzymes do to the rate of reaction? Right here, they speed it up. That's the whole point of having enzymes, like in your digestive system. They speed it up. What happens when an enzyme is denatured? Okay, and that actually goes onto this slide. Okay, so we are on question 37. Denatured means we shut it off. So when an enzyme is denatured, it's shut off. It's not reacting anymore. Okay, I'm on question 38. Is shape important for enzyme specificity? We called it a lock and key model. Yes. Okay, even if we go back to this one, they're very specific. They only work one reaction. They are very, very specific, which is the answer to question 39, and shape matters. Okay, lock and key. Question 40, almost everyone got wrong, and right here is the answer. Okay, what molecule does an enzyme act upon? A substrate. So remember I had Brian put his hands in the air. His hands were the enzyme, the active site. My fists were the substrate. They bound or binded to the active site. So the substrate are the reactants that bind to the enzyme active site. The key fits in the lock. Then we form a complex. The substrate gets changed into the products, the enzyme releases it, and the enzyme gets recycled. So that's what you need to know about enzymes. Okay. Equilibrium. Now we're jumping back up to question 15, the term for a chemical reaction and its reverse at the same time. You should know the word equilibrium, which is Le Chatelier's principle, the only name in this unit. And that takes us to our last chunk of questions. Number 16, differentiate between a heterogeneous mixture and a homogeneous. A lot of you said a homogeneous mixture is one element and a heterogeneous is 2. That's not really the point of a solution and a suspension. So solutions are homogeneous because they're evenly mixed. They're not chunky. Like when I look at salt water, I just see cloudy water. I can't see every individual salt particle. A suspension is heterogeneous because it's chunky, like your blood. Your blood is liquid plasma with chunks, your blood cells floating in it. So homogeneous solutions, evenly mixed, no matter how many elements are in it. Suspensions are something that's chunky, non-dissolved. Okay, so homogeneous solution, heterogeneous suspension. Okay, this takes us to number 18. Why is water the universal solvent? It dissolves pretty much everything. Okay, so you leave a submarine in salt water long enough, it will dissolve. Okay, also this takes us to, I believe it was question 21. What type of substances will not dissolve in water? Nonpolar ones, like fats. And most of you did get that right. Number 17. Most people kind of got in the ballpark of the right answer, but you didn't quite describe it right. Some of you said it was less compressed. Why does loose salt dissolve faster? The key is, if I crush a substance, it has a larger surface area. That's why we have crushed salt, crushed sugar, larger surface area, just like your cube when you ground it up, or your cube of potato in our lab. Okay. Solubility. This takes us to number 19. Which solution is more concentrated, 6 molar or 1 molar? The higher number is always more concentrated. So 12 is more concentrated than 6. 6 is more concentrated than 3. 3 is more concentrated than 1. Bigger number is more concentrated. Okay. And finishing up, number 20. If I tell you the solubility of something, so if I say 50 grams of salt will dissolve in 100 grams of water, and then I tell you you put 25 grams of salt into 100 grams of water, well, 25 is less than 50, so that water is not saturated. It can hold more salt. If I tell you you put 50 grams of salt into 100 grams, well, I'm at its kind of peak. It's optimal, so we can say it is saturated because it's equal. Supersaturated is where you have more salt than the solution can actually hold. So that's what you're looking at. You will have a couple questions on the test dealing with that. Okay, so we just went over concentrated, diluted. You are going to have a couple questions, simple ones, where you have to solve. I will give you the formula. Molarity, how concentrated something is moles divided by liters. You should be familiar with the pH scale. 0 to 6 are acids, 7 is neutral, 8 to 14 are bases, and you are going to have to solve a couple more problems like our quiz. So if I say a pH of 2 and 5, well, 2 to 3, 3 to 4, 4 to 5, that's 3 units. 10 to the third is 1,000 times. So remember, the scale is logarithmic. Okay. So on the test, what are you going to see? Well, if you look at your study guide, we went over all the questions except 22 to 33. Those questions were on your last test. They are not going to be on this test. I put them on here so you'd have a mini review for your final exam in a couple weeks. So 22 to 33, you can write on your study guide, not on test. All the other questions are on the test. So you're going to have 30 multiple choice questions. You're going to have 4 equations that you must balance, and you're going to have to say which type of reaction they are, like synthesis, decomposition, single replacement. You're going to have 2 molarity problems, where I give you the equation, and you're going to have 3 pH problems. Okay, so you can find this link again, if you want, in your Blackboard Unit 4 folder. So I will put this, and I'll say Test Review YouTube link. Okay, so study from your study guide or do the practice test online. Either way, you should be prepared. You will not be allowed to use your notes. And your test is this Thursday. Happy studying!